Alright, so we'll be doing this problem today, and it says, consider the differential equation d of y over d of x equals x over y, where y cannot equal 0. And then it gives us a slope field, and it asks us to sketch a solution curve that passes the point 3, -1, which is shown right here, that is 3, -1, and the solution curve that passes the point 1, 2, right there. And then it says, write an equation for a line tangent to the solution curve that passes the point 1, 2. So I drew this on the graph. This would be the tangent line for that. And then we can find this by taking our differential equation and plugging in the point it gave us. So 1 over 2. And then you still just get 1/2 for that. And then you plug the slope and then the point it gave you, which is 1, 2, back into the original, back into the equation of a line, which is y equals mx plus b. And then from there you can solve what b is, where this tangent line crosses the y-axis, and then we find b to be 1.5, and then our equation would be y equals 1/2 x plus 1.5. Then it asks to find the particular solution of y equals f of x to the differential equation with the initial condition of f of 3 equals -1 in stated domain. So we take our original equation, and we want to move all the y's on one side and all the x's on one side, so we multiply it by y, and then multiply it by dx, and we end up with dy times y equals dx times x. Then we take the integral of this, and then we find that to be 1/2 y squared equals 1/2 x squared plus c. So then we do some rearranging, and we get 1/2 y squared minus 1/2 x squared equals c, and then we just pull the 1/2 out in front. So 1/2 equals y squared plus, or minus x squared equals c. And then we take the 1/2 and divide it over to the other side, and it's still going to be a c, but it's going to be a different value of c, so we marked it as c1. And then you can just take out the parentheses, and then if you plug back in your points, y equals 3 and x equals -1, then you get c to be 28. So then, if you plug 28 back into this equation right here, you find that you can find the equation to be y equals the square root of x squared plus 28. And the domain for this, if you graph it, is all real numbers. And that's it.